On September 11, 2023, a telescope floating 1.5 million kilometers from Earth pointed at a planet called K2-18b. What it found was a molecule that, on this planet, is only produced by living organisms. Dimethyl sulfide. The smell of the ocean. The signature of biology. The scientific team sat on the data for 8 months. They ran the models again. And again. And again. Every simulation said the same thing. There is no known geological process that produces this molecule in these quantities, not at the levels JWST detected. The paper, when it finally came out in April 2024, used the word biosignature 17 times across 43 pages. But it never once used the word life. And that single, deliberate omission tells you everything about where we are right now and what we are terrified to admit. For 60 years, the question of whether we are alone in the universe was theoretical. Philosophers debated it over wine. Poets dreamed about it in verse. Scientists pointed at the Drake equation and shrugged, too many unknowns, too many variables, too many assumptions stacked on assumptions. But in the last 18 months, something fundamental shifted. We stopped asking if and started asking when. And more importantly, what then? The James Webb Space Telescope has now identified potential biosignatures on not just one, but 3 separate exoplanets. K2-18b, with its dimethyl sulfide and methane. LHS 1140b, a rocky super-Earth with atmospheric nitrogen and possible water vapor. And most recently, a world in the TRAPPIST-1 system that NASA's internal review team flagged for what they called anomalous atmospheric chemistry, their words, not mine. As MIT astrophysicist Dr. Sarah Seeger, who has spent her career searching for exoplanet atmospheres, put it in a 2025 interview, we are now in the era where detecting life is a question of signal-to-noise ratio, not capability. Translation: we have the tools. We have the targets. We're just not sure we're ready for the answer. Here's what most people don't understand about biosignatures. They are not photographs of alien creatures. They are not radio signals from intelligent civilizations. They are chemical fingerprints, specific gases in a planet's atmosphere that absorb very specific wavelengths of light. JWST doesn't take pictures of exoplanets directly. It watches them pass in front of their host stars and measures what the starlight looks like after it has been filtered through alien air. If the light is missing certain wavelengths, those wavelengths were absorbed by molecules in that atmosphere. And if those molecules include combinations like oxygen plus methane, which react with each other and should not coexist without something constantly replenishing both, or dimethyl sulfide, which on Earth has exactly one known large-scale source and that source is marine algae, you have what scientists cautiously call a biosignature. The problem is, biosignatures are not proof. They are statistical arguments. They are probabilities dressed in the language of spectroscopy and atmospheric modeling. And the probability that K2-18b hosts some form of life, according to a peer-reviewed 2024 paper in the Astrophysical Journal Letters, is now conservatively estimated at above 50%. Let that sink in. The smartest people on the planet, using the most advanced scientific instrument ever built, are now saying in careful, qualified, peer-reviewed language that it is more likely than not that we have found evidence of life on another world. And yet, if you ask any NASA official to say those words directly, they will not. Because the standard of proof demanded for this particular claim is unlike anything else in modern science. You can announce a new fundamental particle at CERN with 5 sigma confidence, roughly a 1 in 3.5 million chance of being wrong. That is the gold standard for physics. But for extraterrestrial life, some astrobiologists argue we need 8 sigma. Others say nothing short of a physical sample return mission, sending a probe 124 light-years to scoop up alien air, will ever be sufficient. What almost no one says out loud is that this impossibly high standard has nothing to do with scientific rigor and everything to do with institutional fear. Visual, probability scale graphic, needle moving from unlikely to more likely than not mood, tension, the fear is not irrational. History shows that every single time humanity has been confronted with evidence that it is not special, not the center of the universe, not uniquely created, not the only intelligent species in existence, the revelation has been violently destabilizing. When Copernicus published his heliocentric model in 1543, the Catholic Church banned his book for more than 200 years. When Darwin published On the Origin of Species in 1859, it triggered a crisis of faith and philosophy that, 160 years later, still has not been fully resolved in significant portions of the world. Now imagine confirming that life exists elsewhere. Not microbial fossils on Mars, we might collectively handle that, file it under interesting but ancient. But an active, living, breathing biosphere on a planet 124 light-years away, with atmospheric chemistry that looks suspiciously like it was produced by organisms. The psychological impact of that discovery, According to a 2024 study by Arizona State University's Interplanetary Initiative, one of the first research groups to seriously study public reaction to extraterrestrial discovery scenarios would be comparable in magnitude to a global religious event. And not necessarily a unifying one. The study, which surveyed over 7,000 people across 24 countries, found that while 56% of respondents said they would feel excited by the confirmed discovery of microbial extraterrestrial life, 27% reported it would cause them significant existential distress. 15% said it would fundamentally challenge their religious beliefs. 11% reported they would experience symptoms consistent with clinical anxiety. These are not small numbers. Extrapolate them globally and you are talking about potentially hundreds of millions of people experiencing a crisis of meaning simultaneously across every culture, every faith tradition, every political system. The scientists in that conference room in 2023 were not just debating spectral lines and signal-to-noise ratios. They were staring at the original sin of human knowledge. Once you know something, you can never unknow it. And they were genuinely uncertain whether the rest of us could handle the weight of what they had found. Consider what happened during the COVID-19 pandemic. A virus, something we could see under microscopes, sequence, and eventually vaccinate against, still fractured global society along every fault line imaginable. Trust in institutions collapsed in real time. Scientific consensus became a culture war battlefield. Now multiply that by an order of magnitude. Replace a virus with a discovery that challenges the most fundamental assumption most humans have ever held, that we are unique, that consciousness is ours alone, that Earth is special. There is no playbook for this. There is no government agency charged with managing the social fallout of discovering we are not alone. There is not even an international agreement on how or when to announce such a finding, just a loose set of guidelines from the SETI Institute that most mission teams treat as optional reading. Visual, human hands of different ages reaching toward bright light source, mood, hope. But here's the twist that almost no one in the scientific establishment wants to discuss publicly, and it's the part that should genuinely worry you. We may not get to decide when or how this announcement happens. The institutional gatekeepers, NASA, the peer-review journals, the university press offices with their embargo policies and carefully worded releases are increasingly irrelevant to how the public actually learns about major scientific discoveries. Because in 2026, information does not wait for permission anymore. In December 2024, a preprint appeared on R14, the open-access server where physicists and astronomers post papers before they go through formal peer review. The paper, authored by a team of researchers from 3 countries, claimed to have identified what they called periodic spectral modulation consistent with a biogenic source on a rocky planet in the TRAPPIST-1 system. Within 48 hours of posting, it had been downloaded 2.3 million times. It was trending on X. It was covered on the evening news in 17 countries before any journal had even assigned it to reviewers. The paper's authors had not cleared their findings with NASA. They had not waited for the multi-year peer review process that traditionally gates claims of this magnitude. They just published. And this is the real collision coming our way, faster than most people realize. The slow, careful, consensus-driven machinery of institutional science is about to be run over by the speed of open-access publishing, social media amplification, and a global public that has been primed by 60 years of science fiction to expect this exact moment. The famous Fermi paradox, if alien civilizations exist, where is everybody? Assumed that contact would be unmistakable, a radio transmission, a starship arrival, something unambiguous and undeniable. But we might be getting the answer through a completely different channel, a data dump on a physics preprint server at 2 a.m., a leaked internal memo from a mission team that couldn't agree on messaging, a scientist who decided the public deserved to know what the instruments were showing before the journals gave them permission to say it. The question is no longer are we alone? The question has become, who gets to tell the story first and what happens to all of us when they do? Visual, Enrico Fermi's historical portrait, slow dissolve to modern ALMA radio telescope array, mood. Mystery, visual, Earth from space at night, city lights tracing continents, the boundary between known and unknown, mood, wonder, here is what I believe. We will have confirmed, publicly acknowledged evidence of extraterrestrial life within the next 10 years. Not maybe. Not if current trends continue. We will. The technology already exists. The targets have already been identified. The data is already suggestive to the point where the only remaining variable is institutional willingness to say the words. What we lack is not scientific capability. It is courage. Courage to say what the data is increasingly telling us. Courage to accept that humanity is not and never was the singular center of the biological universe. Courage to admit that the very institutions we built to guard and validate knowledge, NASA, the journals, the academic hierarchies, are now the primary obstacle to sharing it. Every day that the scientific establishment delays, qualifies, hedges, and buries findings in cautious language, they are not protecting the public from a crisis of meaning. They are guaranteeing that when the confirmation comes, and it will not come from them. It will come from a preprint server at 2 a.m. It will come from a whistleblower inside a mission team. It will come from a leak. And when it does, we will have had zero preparation, zero public conversation, zero collective processing, because the very people who should have been leading that conversation for the last 2 years were too afraid to start it. This is not a debate about spectroscopic analysis or atmospheric modeling. It is a debate about whether institutional science still serves the public it was created to inform or only protects itself. Visual, iconic Earthrise photograph from Apollo 8, slow zoom out revealing more stars, mood, wonder. Next week on Future Frame, we are going deeper into the technology that is making this search possible and the artificial intelligence systems that are now demonstrably better than humans at finding biological patterns in astronomical noise. Because the first entity to discover alien life might not be a person at all. It might be a machine. And that raises a question that no one has a good answer for. What happens when an AI discovers something that fundamentally changes what it means to be human? And we are not sure whether to believe it. Visual, fully automated robotic observatory, telescope dome opening, mechanical precision under stars, mood, wonder.